welcome to equation of a tangent to a circle. Just before we start, just a reminder that there is a notes jotter available for this video. Just check the description below for a download link and you can work along with me as we go through the video. Okay, so the first thing that we really need to look at is actually the equation of a circle. So any circle will always be in the format of x squared plus y squared equals some number. I've drawn the circle x squared plus y squared equals 25 on this graph, and you will notice that the outer edges are all hitting at 5s around the outside, and the reason for that is that the radius of the circle will always be the square root of this number. So that is just something that's there to have in mind. If it is a circle of the form x squared plus y squared, it will have a centre at 0, 0, and its radius will be the square root of the number at the end. Now that's important because we may need to actually think about the dimensions of the circle when we come to answering questions on it. What you will also notice here is I have added a tangent to this circle. This circle has a tangent in blue, and I've also drawn the radius in red. Now you should remember from circle theorems a little rule about tangents and radius, and that is that they will always meet at 90 degrees. Now what that means is that the tangent will be perpendicular to the radius. So that now links into previous videos on finding the equation of perpendicular lines. You need to have a firm grasp on that before embarking on this topic, because you need to be able to calculate the equation of perpendicular lines throughout this task. Now what we are looking for in these situations, we're generally trying to find the equation of this tangent, the one that is just touching on the edge of the circle. And to do that we need to first know the equation of the radius, and that's quite a straightforward one, because it's going to be in the form of y equals mx plus c, but we know straight away that it is going to start at 0, 0. It's going to cross the y-axis at 0, therefore there is no c. All we need to know is what the gradient is. And this point here is what is always going to be important, the point where the radius meets the tangent. And in this case it is 4, 3. Now what that means is I can straight away just place onto my diagram a little triangle. I know that from 0, 0 it's gone along 4 and up 3. So I can get the gradient from those two dimensions. It's gone a change in y of 3 and a change in x of 4. So the gradient of the radius would be 3 over 4. And so the equation of that line will be y equals 3/4 x. Now the next stage is that we want to find the equation of the blue line, the tangent. And so because we are doing that, we need to start thinking about the gradients of perpendicular lines. Now you'll have seen in a previous video that the gradients of perpendicular lines must multiply to make -1. We need the negative reciprocal of this gradient, and so the negative reciprocal would be 4 over 3. That would be the reciprocal, but the negative version would be -4/3. And so this equation, the tangent, would have to be y equals -4/3 x. But this one would include plus c. And in order to work out the value of c, we need to now use this coordinate. Remember, a coordinate always gives us an x value and a y value. So we can substitute those values in. That is 3 equals -4/3 of 4 plus c. And so how do we work out the value of c? Well, we now just actually work out each of these elements. So -4 over 3 times 4 would be -16 over 3 And if we keep going, that would mean that I would then need to add 16 over 3, and we can bring up our calculator to do that. We can do 3 plus 16 over 3, and we get 25 over 3 as our value for c. So if we bring that back to the start, that means that our equation of the tangent would have to be y equals negative 4/3 x plus 25 over 3. And if we really wanted to, just to make this look a little bit nicer and a little bit neater, we could multiply through everything by 3 so we don't have fractions anymore. So we could call that 3y equals negative 4x plus 25. So in our next example, we don't have any values drawn onto our diagram, but we do know we have a circle with a centre of 0 and we have a tangent to that circle. The circle has the equation of x squared plus y squared equals 20, and the point P lies on the circle at the point 3 root 11. Find the equation of the line. Now straight away you might notice that we're now dealing with surds. That can happen within these questions because we are dealing with square roots based on the fact that we've got a little bit of Pythagoras going on within the diagram in order to find the radius. So it is likely that we will see surds coming up. Now what we need to begin with here is just drawing in our radius, because the radius will join point P at a right angle, and we know the value of point P. We know that it is 3 root 11. Now what that tells me is that if I were to form a triangle, that I can say that that must have gone 3 to the right and root 11 up. So I know that this length is 3 and this length is root 11, and so the gradient of this radius will be root 11 over 3, meaning that the equation of that line is y equals root 11 over 3 x. Now beyond that, we know that we have a tangent. The tangent will have a gradient which is the negative reciprocal, and so we need to just deal with the negative reciprocal of this, which would be 3 over root 11, but it would be negative, and so this tangent would have an equation of y equals negative 3 over root 11 x, and again plus c. We know it's got a definite point of intersection with the y-axis because it's crossing up here. Now in order to work out the answer to this, we're going to have to do some substitution. Again, we're going to need to use the coordinate, the only coordinate we've been given, 3 root 11, in this formula. So y was root 11, and that's going to be negative 3 over root 11 3 plus c, and we're going to have to do a little bit of working out here. So multiply together, we have negative 9 over root 11 and root 11 plus c, and in order to get c all on its own, well, I'm going to have to add 9 over root 11, so I'm going to have root 11 plus 9 over root 11. Now if this was on a calculator paper, this would be nice and straightforward. We could just type that in and get an answer, but given that it's surds, it may well be on a non-calculator paper, testing your knowledge of adding together fractions which include surds, and therefore we're going to have to just deal with that. So if I need to add together these two things, first of all I want to turn this first value into a fraction, and so I'll just call it over 1, because that will mean that I'm adding together two fractions. If I need to add together fractions, the two denominators need to be the same, which will mean that I want root 11 at the bottom of each fraction. And so this one hasn't changed, but the first one, everything has been multiplied by root 11. Root 11 times root 11 is 11. That gives me 20 over root 11. That is absolutely fine as an answer, although we do generally like to rationalise the denominator. We don't like to have surds as the denominator in a fraction. So the next thing I would just do would be to multiply the top and the bottom by root 11. If I multiply by root 11, it gives me 11 on the bottom, which is now rational, but at the top I would have 20 root 11. That is the value of c. That value needs to go back into the equation that we came up with here, and so the equation of that tangent would be y equals negative 3 over root 11 x plus 20 root 11 over 11. We could also rationalise this denominator just to clear things up a little bit. So that would give me, if I was to rationalise this, multiply the numerator and denominator by root 11, I would have negative 3 root 11 over 11, and that would give me this as my equation. So y equals negative 3 root 11 over 11x plus 20 root 11 over 11. And again, just to neaten things up a little bit again, we've got two fractions which both have denominators of 11. So if I multiply by 11, it removes the fractions. Let's call it 11y equals negative 3 root 11 x plus 20 root 11. Okay, so we now have the same idea. We've been told M is the circle with equation x squared plus y squared equals 100, and the point N lies on the circle at 6, 8. Find the equation of the tangent to the circle at N. Now you might want at this point just to do yourself a little sketch just so you can get an idea as to what is going on. So we know it is a circle. We know that that would be with a centre of 0, 0. And we then know that there will be a tangent at about 6, 8. So the tangent is going to be around here. Now that's just there to give us an idea as to what we're dealing with. You don't need the sketch if you're feeling confident with the topic, but it is there just to help. And so x squared plus y squared equals 100. Well, that bit there tells me that the radius of my circle must be 10. And so I can add that information in as well. I know that each of these intersections are going to be 10s, and that 6, 8 is going to be around about here. So find the equation of the tangent to the circle at N. So the first thing that I want to do is actually think about the radius again. So the radius is going to go from 0, 0 to 6, 8. So if I draw in my triangle, I can tell straight away that the gradient of that line, it's going to be 8 over 6. 8 over 6 as the gradient, which is the same as 4 over 3. So the first part is that this one is going to be 4 over 3x. That is the equation of the radius. The tangent is then going to be using the negative reciprocal. So the negative reciprocal, let's go with the reciprocal first, 3/4, but it's the negative. And so it's going to be y equals negative 3/4 x and plus c. Yet again, it's a c, a value that we need to actually calculate, and we will get that value using the coordinate we've got. We're going to replace x with 6 and y with 8. So 8 equals negative 3/4 of 6 plus c. And so if we work that out, that's 8 equals negative 18 over 4 plus c, and so I'm going to do 8 plus 18 over 4. So if we do that, we get 25 over 2 is c, and we can place that back into our original equation. Y equals negative 3/4 x plus 25 over 2. And again, let's just smarten this up a little bit. Let's get rid of the fractions at the bottom. Easiest way to do that would be to multiply both it all by 4. So 4y equals negative 3x plus 50. And so we end with our exam question. This was on the Edexcel paper in June 2017, and it was on higher paper 2. Now that's useful because it's telling us that it is a calculator paper, so we can use that when we need it. So we're told that L is the circle with equation x squared plus y squared equals 4, and point P is 3 over 2 root 7 over 2, and it's a point that is on the circle. Find an equation of the tangent to L at the point P. So again, with this being a question about a circle, you might want to just give yourself a little sketch of a circle, just so you can keep track of what's going on. Again, the format of the equation tells me that the centre is going to be at 0, 0, and it also tells me that the radius of that circle must be 2, because that's the square root of 4. So I can tell that this is going to be crossing our values of 2. And then we have our point, 3 over 2 root 7 over 2. So that is going to be somewhere around here on our circle, because we're looking at 1.5, and therefore our tangent is going to be just hitting the circle around there. Now obviously this is a sketch, it has actually gone through the circle there. If you want to, you can smarten that up, but as it's a sketch, it's just there for you to be able to tell what is going on in the question. So first of all, we want the radius of this circle, and that is going to be formed from this point. So we know that in the x direction, that is 3 over 2, and in the y direction, it's root 7 over 2. And so if I were to find the gradient, I need to divide the change in y by the change in x. So I've got root 7 over 2 divided by 3 over 2. Now if you want to do this, you could do it with a calculator, or you can use the quick rule of copy, change and flip. So we would actually have root 7 over 2 times 2 over 3, which gives me 2 root 7 over 6. And that is the same as root 7 over 3. That is the gradient of the radius. And so that gives me that the radius would have the equation y equals root 7 over 3 x. Now we're dealing with the tangent, therefore we need to do the negative reciprocal of this for the gradient of the tangent. So that is going to be y equals negative 3 over root 7 x, and it's going to be plus c. And again, all I'm now going to do is substitute in my coordinate into the equation. So that is going to be root 7 over 2, replacing y, and negative 3 over root 7 times 3 over 2 plus c. And in order to work this out, I'm just going to make a quick quick bit of working out on here. So root 7 over 2 equals negative 9 over 2 root 7 plus c. And now, as it was a calculator paper, let's use the calculator to answer that question. We need to add the add the 9 over 2 root 7, and so I've got root 7 over 2 plus 9 over 2 root 7, and we'll find out our answer is 8 root 7 over 7. Now that has already rationalised the denominator for us, that's all just to make things a little bit easier. And so this value for c is going to come out up here, y equals negative 3 over root 7 x plus 8 root 7 over 7. And again, if we just want to neaten things up, we can rationalise this denominator. That is going to mean that we have y equals negative 3 root 7 over 7 x plus 8 root 7 over 7. And just to smarten it up a little bit more, let's multiply everything by 7. 7y equals negative 3 root 7 x plus 8 root 7.